Chapter 21, Part 2. Just in case you were confused, this is where we left off with wave energy. Okay? So, here you can see the exact thing. Here it's just the water is physically turning the turbine. We're not generating heat to cause water to produce steam to turn the turbine. We're just... Probably doesn't make that noise. Just a heads up. Okay? So, coastal areas with large differences in height between high and low tides can use tidal energy. Water rushes in, water rushes out. Guess what it does? I know, it turns a turbine. Okay? South Korea's... no one wants me to pronounce that. Tidal power plant is the largest facility that uses this source of energy. Do you need to know they're the largest facility? No. Do you need to understand what it is? Yes. Okay. Each day, the ocean absorbs massive amounts of heat from the sun. Because the sun provides, they did it on the other slide. If you were paying attention to part 1, okay, the sun provides enough energy every day for the planet for 25 days. Most of it lands in the water. Now we're talking about it landing in the water. Each day the ocean absorbs massive amounts of heat from the sun, making the surface warmer than the deeper waters. Ocean thermal energy conversion is an experimental approach, so probably not going to happen in my lifetime, maybe yours, I don't know. It just depends. Okay, I could live to be old as crap. Okay, is an experimental approach that uses this temperature gradient to generate power. The closed cycle approach pipes warm surface water to a facility to evaporate chemicals such as ammonia that boil at low temperature. The open cycle approach evaporates warm surface water in a vacuum and uses the steam to spin a turbine. I feel like I'm saying that word over and over again. Do you feel it too? Are you feeling that with me? Okay. So here we have hydrogen and fuel cells. I told you. My friend has a hydrogen car. We've talked about it. It pees out water. Remember? Okay. For the 3 of you that were listening to that conversation, I know it's coming up now. So the biggest limitation to renewable energy is the difficulty in storing energy. Fuel cells use hydrogen as a stored power source. You guys do know, for the majority of you who took chemistry, hydrogen, the most abundant element. And if you don't, now you do. Welcome aboard. Okay? So here's how it works. Hydrogen molecules are stripped of electrons and then you read it, and then you read it, and then you read it, and then it pees out water. That's the end product. Okay? So what are we giving off? Water. It's actually liquid water. It's not steam. So it's not contributing to greenhouse gases because water in the form of steam in the air as temperatures rise, that is a greenhouse gas. I know, it's weird. But as liquid, no. All right, it releases energy when it combines with oxygen to produce water. No pollution. So transitioning from gasoline to hydrogen could alleviate dependence on foreign fuels and help reduce greenhouse emissions. That lead to what? Climate change. See how they tied that together? To reduce greenhouse emissions that lead to climate change. I feel like you should answer all FRQs if you're talking about greenhouse gases that lead to climate change. By storing energy, you could see how you could write that out with an FRQ. So many cities have begun converting their bus fleets to run on hydrogen cells. Okay? There's the chemical equation, just in case you wanted it. The process of electrolysis uses electricity to split water molecules into molecules of hydrogen and oxygen. The cleanliness of hydrogen depends on the power source used to generate it. Fossil fuel combustion or a new renewable energy source. So if you tie that in order to make the hydrogen fuel to a solar array, well, then you have a clean energy source. If you, however, hook it up to an electric power plant that's still burning coal, well, then that's kind of been counterproductive. So hydrogen can be extracted from other molecules like methane at a lower energy cost, but with more pollution produced. So why would we do that? Don't do that. So here we go. The chemical reaction involved in producing electricity from hydrogen in fuel cells is the reverse of hydrolysis. So hydrogen gas is allowed into one side of the cell, and the movement of these hydrogen electrons from one electrode to the other creates the output of electricity, okay, and the product, water. So, converting a nation's infrastructure, this is where there's a problem. Oh my goodness, I should just let you talk to my friend and she can complain for hours about the hydrogen situation out there in California. They're the only ones that have hydrogen stations. Sometimes they have them, sometimes they don't. Sometimes it's a compressed gas and she puts it in and then it gets like frozen to the car. Issues. Working on them. Baby steps, but at least steps, right? So, converting a nation's infrastructure to hydrogen will require massive and costly development of facilities to transport, store, and provide the fuel. The leakage of hydrogen could potentially deplete stratospheric ozone, which would suck, because we're a fan of that, you know, UV radiation coming down, okay, and increase the atmospheric lifetime of the greenhouse gas methane. Try not to release the hydrogen, because we don't have hydrogen just floating around. It's combined with something. It has many benefits. It's the most abundant element in the universe, so we won't run out. Using hydrogen to generate electricity generates no air pollution. Fuel cells are very energy efficient, 35 to 70%, which is huge. Hydrogen, what is your waste? Go watch some YouTube videos on how hydrogen cars pee. It's funny. Okay, it's currently experimental. Ta-da! Start studying.